So the distance d in meters covered by a child traveling along a flat water slide along the ground after time t in seconds is shown on the graph. So, okay, here is time passing. This is their distance on this water slide that's shooting them across. It says, describe the speed of the child during the first 2 seconds. Notice that in the first 2 seconds, which is like right here, that it starts off really steep. Really steep equals fast, right? Over a short period of time, they jumped a lot, right? So this idea of, oh, you went really fast in a very short amount of time. And so this idea of this slope being pretty steep right there, but then notice how the slope gets less steep and less steep and less steep as we move along this curve. And so by the time you're up here, you've got a completely different slope than you did at the beginning. And so you can see that behavior starting in the first 2 seconds. That really steep equals fast, but less steep equals slowing down. And the opposite could be true here. So looking back to this drive, right? This curve right here, the solid line shows, oh, really fast at first and then slowed down. Maybe they hit a highway at first and then they had like backwoods roads at the end, so they had to drive a lot slower. On this guy, it says, hey, we drove really, really slow. And then as we got closer, we ended up going really fast. So maybe Livingstone is a city. And so when you get to a certain point, there's lots of highways that zoom into the city. And so maybe that's what that is representing. I don't know, but that's the idea here, is that more steep equals going fast. When it's less steep, it equals slowing down. Or if it starts off really not very steep, then it's slow. And then if it gets steeper, then it's going faster. So connecting that idea of slope and speed. So if we were to write about this in a more conceptual way, we would say when the child got on the slide, they were really fast at first. And then they slowed down. So trying to relate back to what you know about being on those water slides, not like one that goes like this, in which your speed might increase, right? It says a flat water slide. So if you've ever like had a little plastic tarp down and put water all over the plastic tarp and got your bathing suit on and you and your friends slid across the tarp, what's something that happens when you first start? You get a running start and you jump onto the slide and then you start slowing down. Why might you start slowing down? Hopefully bringing in something that we know about science and something that we know about physics and something that we know about just everyday experiences. Friction, right? What happens, and maybe some of you got like on your belly is a little raspberry of when you get going at first, you've got all of this water situation going on between you and the slide. And then as you go, the water is dispersed and spread out and there's less water there. And so then the plastic tarp starts to rub at you, and the rub is what ends up slowing you down. That friction causes momentum to slow down. So that's what happens, is that it was really fast at first, and then because of the friction of the plastic, you started to slow down, or the child started to slow down. Keeping this in mind as we go into the next problem, it says draw suitable tangents to the graph. Definition: tangent. A tangent is a line. A line is straight. Don't write a straight line. A line is this. This is a line. This that bends and isn't straight is not a line. It's a curve. That's one of my biggest pet peeves. Lines are straight by definition. They have a constant rate of change, so they are straight. Curves bend. A line, sorry, off my podium. A line that just touches the graph at a certain point. So as I was showing you with my pencil on this guy before, I was like, hey, look, like, okay, it's really steep here. And then I was just trying to like kiss this this curve as I'm talking about what's going on as we continue. And that is a tangent line. This idea of like, oh, okay, we're a tangent line. So it says draw suitable tangents to the graph and find the speed of the child at that point. The speed, when we're talking about a line, is the slope of that line, right? Your slope is the speed. Since we have an ever-changing slope, your speed at that point is the slope of the tangent line. So if you wanted to know, okay, at this point, how fast is she going, or he, then you would look at the slope of this tangent line and say, oh, change of distance over change of time. It's the average or the instantaneous rate of change there. Average was here between 2 points. Instantaneous is talking about 1 point. So I want you to try your best, and I want you to, it doesn't have to be exactly like mine. And I know that what I'm about to draw here is going to be different than what's on my answer key. So it doesn't have to be the same, but I want you to try and get a feel for what a tangent line is. So I want you to take a ruler or your cover to your calculator, and I want you to kind of eyeball of like, hey, this looks like it would just barely touch this. Now I could do this, but that looks a little bit less. I want it to almost be like balancing, kind of this balancing act on top of that curve. And then draw your best line. So let's talk about A. I'm going to look at this line that I just drew, and I'm going to try and grab points that I think are good. This looks like a good point because it goes through the crisscross. And this looks like a good point because it goes through the crisscross. And yours might be slightly different. But notice that my slope is up 1, 2, 3. Let's do approximate because we're guessing this tangent line. Oh, you can't see what I'm writing. Approximately 3 over, and then your run is 1, 2. So my slope is approximately 1.5. On my answer key, when I drew it, I did this, and I said 4/3, right? So it's not going to be the same. So if you got somewhere between 1.25 and 1.75, you're probably in a good spot. If you got something outside of that range, then you're probably looking at drawing that line a little bit too freely. And I just want you to, I want to encourage you to try your best to make it, think of it like you're balancing this line on top of a finger. And hopefully that'll help you visualize it. So this is a slope. It's the slope at that point because it changes. The slope will change on a curve, not with a line. And so we had to first be like, okay, well, what is the idea of a line if it was at that point, if it was following this curve? And so we had to draw one first and then just pick nice points and find a slope. This is still a rate of change. It's still your speed. So it's the change in y, which is meters, over the change in x, which is seconds, time. So the speed, the instantaneous speed at point A is about 1.5 meters per second. Versus B. B, I want you to go ahead and try and do on your own. Going in here and trying to get a general idea of like balancing something flat on this curve and trying to like represent that idea as best as I can. Drawing the line out as far as you, as far as you can, it gives you more points that you can choose from, right? So I want to look for nice, easy points. That looks like a nice, easy point. That looks like a nice, easy point. So my rise is 1, 2. My run is 1, 2, 3, 4, 5. So my slope is about 2 over 5, which is about 0.4, again, meters per second. Mine, when I did it the first time on the answer key, 0.43. So compare, contrast, about the same. As you can see on my notes to myself to tell you, hey, if you think about that idea, comparing it to what we know and what we've figured about this situation in this graph, we start off really steep In other words, a faster speed at the beginning, and then we slowed down towards the end. So this is also agreeing with this concept in part A, and that's crucial that when these parts all should be agreeing with each other in these IB questions. And so just always, kind of like your IA, always reference back to what you just did and say, does that make sense in the context of this situation? Yeah, that makes sense in the context of this situation. Okay, so that ends the two things that I wanted to talk to you about before we combine them together next lesson. We're going to combine together this idea of a tangent line and the slope of the tangent line, and the idea of a limit. And then how do we use this in a more mathematical and formulated way as opposed to guessing. Good job. You're doing it. Calculus, it's happening.